Okay, in this video we are going to look at how to find out the sum of the squares of an arithmetic progression. So we will show how to find the sum of the squares of any general arithmetic progression. Okay, so let's say our arithmetic progression is a plus d, a plus 2d, and nth term is a plus n minus 1 times d. Okay, we have already seen what arithmetic progression is, and this is generally how we describe an arithmetic progression. So for making it concise to write, I will call the first term as a1, second term as a2. So a2 is a plus d, a plus 2d is a3, and similarly this is going to be a n, right? And so we have n terms of arithmetic progression with the first term as a and the common difference as d, right? Now to find the sum of the squares of an AP, there is a general way of doing all these problems. If we have to find the sum of the squares of an AP, we consider the expression a n cube minus a n minus 1 cube, right? So we take, suppose we want to find out what is a n cube minus a n minus 1 cube. How can I write a n minus 1? I can write a n minus 1 is equal to a n minus d, right? Because the term which is just before a n is going to be smaller by the common difference, right? So this means that this can be written as a n cube minus a n minus d cube, and this can be written as a n cube minus a n cube minus 3 a n square d plus 3 a n d square minus d cube, and if we open the brackets, this a n will cancel and you will be left with 3 a n square d minus 3 a n times d square plus d cube, right? Now I want you to remember this expression. So now let us see, we can write, we have already seen that we can write a n cube minus a n minus 1 cube is equal to 3 times a n square d minus 3 times a n d square plus d cube. What is going to be a n minus 1 cube minus a n minus 2 cube? This is going to be 3 times a n minus 1 square times d minus 3 times a n minus 1 times d square plus d cube, right? And if we go on, we can write a2 cube minus a1 cube is equal to 3 times a2 square d minus 3 times a2 times d square plus d cube. Now we can do one interesting thing. We can add the left hand side all the equations and right hand side all the equations. What happens if we add left hand side? We see that this a n minus 1 cube and plus a n minus 1 cube will cancel. So what I'm saying is that this term over here will cancel with this term, and similarly a n minus 2 cube will cancel with the next line of this the next row, and similarly a2 cube will cancel with the previous row. So all you will be left with is, on the left hand side you will be left with a n cube minus a n a1 cube. This is going to be equal to 3 times a2 square all the way to a1 square, sorry, a n square times d minus 3 a2 plus all the way to a n times d square, plus we will add all the d cubes, right? How many d cubes are here? You can see that they are going to be n minus 1 d cubes plus n minus 1 times d cube. Why? Because you can see the rows are going from a2 to a n, so there are n minus 1 rows over here. So this is d cube is added n minus 1 times. Now if I add a n cube minus a n a1 cube and I add plus 3 times a1 square d and I subtract 3 times a1 times d square. Now this 3a1 square d will also add on the right hand side, so this becomes 3 times a1 square plus a2 square plus a n square, and this is what we have to find. So this becomes 3 times d times sigma of ai square. I is running from 1 to n. This is what you have to find, right? Minus 3d square, and you can see if I have minus 3a1 d square here, this will also add over here, so this will become a1 plus a2 plus an, and this is nothing but the sum of the arithmetic progression, right? So this is the sum of the arithmetic progression, for which we already know the formula. So this is sum of ai. I is again running from 1 to n plus n minus 1 d cube. Now you can see that we know almost everything. All we have to do is just simplify this hairy looking expression. We know what is a n, we know what is a1. A n is simply equal to a plus n minus 1 d. a1 is equal to a, and we just substitute these values and we have to simplify for this expression over here. Okay, this is what we have to find. we already know how to find the sum of an AP. We have already seen this, right? So let us simplify this. We will simplify this in stages because this expression is very lengthy. So what is a n cube? A n cube is a cube plus 3 times a square times n minus 1 times d plus 3 times a times n minus 1 square d square plus n minus 1 cube d cube. Okay, so this is a n cube minus a1 cube. Minus a1 cube is simply minus a cube plus 3a1 square d is simply plus 3a square d, and minus 3a1 d square is simply minus 3a d square. Now I want to bring this plus n minus 1 d cube to this side, so this becomes minus n minus 1 d cube, and this 3 times d square ai becomes plus 3. Let me write it below the terms of d square. Okay, so I can write it here, plus 3 times d square and the sum of the AP, which is n by 2 times 2a plus n minus 1 times d, right? So this is 3d square times sum of an AP, for which we already know the formula. We know that the sum of an AP is n by 2 times 2a plus n minus 1 d. And what is all these expression equal to? This is equal to 3 times d times sigma of ai square. I is equal to 1 to n, right? So this is 3 times d times sum of the squares of an AP. Now all we have to do is simplify this expression. So a cube cancels this a cube, and if I consider these two, I can take 3a square d as a common factor out. So this is 3 times a square d as a common factor out. Now this is n minus 1 plus 1, right? N minus 1 plus 1 is n. So now we have handled this term and this term. Now let us handle this term. This is d square d square. So let us take 3a d square as a common factor out. So plus 3 times a d square. If I take this as common factor out, this is n minus 1 square minus 1. What is n minus 1 square? It is n square minus 2n plus 1 minus 1. So it will be n square minus 2n. I am skipping some steps because I want to finish this video in a shorter time, but you can do all this by yourself and you will see that this is going to be equal to this. So we have handled these two expressions also. From here I can take out n minus 1 times d cube as a common factor out. So this is plus n minus 1 times d cube. Now what will be left? This will be n minus 1 square again minus 1. So n minus 1 square is just like before, it is n square minus 2n plus 1 minus 1. So we will be left with n square minus 2n here. So we have handled this term as well, and the last term that we have to handle is this one. So this is equal to, if I just expand it, this will be equal to 3d square so yeah, so it will be 3 times a times d square n, right? 3 times a times d square, this is 3 a d square and n by 2 and 2 cancels times n, plus 3 times d cube so 3 by 2 times 3 n n minus 1 times d cube divided by 2, right? So it is 3 by 2 n times, yes. Now again this expression, you have to remember that this expression is equal to 3 times this. So let us call this as 3 times s, and this is what we have to find. So now for proceeding on to next step, we'll copy this onto the next page. Right, so far we have seen that 3 times s is the sum of the squares of an arithmetic progression, times d is equal to this expression over here. And how did we get this? I have already shown this working over here. This was the 3 times d times sum of the squares of an AP. So I am calling this expression in the sigma as s. This is what we have to find, and now we will see how to simplify it further. We can see that we can cancel d's from both sides of the equation. So this gives 3 times s is equal to 3 a square n plus 3 times AD, and n square minus 2n I can take out common factor as n. This is n times n minus 2, right? Plus now d cube will become d square over here. Again I can take n as common factor out, so this is n times n minus 1 times n minus 2 times d square plus 3 a d n plus 3 by 2 times n minus 1 times d square. Now you can see that n can be taken out as a common factor, and because there is a term 2 here, let me take n by 2 as the common factor. So this becomes, the right hand side can be written as n by 2 times, this becomes 6a square this becomes 6ad times n minus 2 plus this becomes n minus 1 n minus 2d square, or I can write it as n square minus 3n plus 2d square. There is a reason I am expanding it, because in the end we'll have to simplify, collect all the terms of d square and cancel each other. This becomes plus 6adn 6ad because n has been taken out. Yes, and this last term over here becomes 3 n square minus 3n d square, right? 3n square minus 3n. Oh, I'm sorry, n has been taken out as a common factor, so this becomes 3n minus 3n minus 3 d square. You just have to be little careful while doing this algebra, because there are chances of making a mistake here, and if we make a mistake here, then we have to go all the way and repeat all these steps. Now this means that this is n by 2 times, now I'll just collect the terms, so this becomes 6a square plus I can take 6ad, so this one is handled already, so 6ad and 6ad, so I can take 6ad as a common factor out, and this becomes n minus 2 plus 1. N minus 2 plus 1 is n minus 1 plus I can take d square as a common factor out. So if you take the d square as a common factor out, you will get d square times n square minus 3n plus 2. So this becomes n square minus 3n plus 2. I hope I have, oh yes, this over here, because this is a 2 n by 2 over here, we have forgotten to multiply this by 2, so this should be 2 over here, right? Yes, so this will be actually over here, it should be 2. Yeah, so n by 2 times, yes, so now this will be 2n square minus 6n plus 4, this is correct, plus 3n minus 3, and this will simplify further. This is n by 2 times 6a square plus 6ad n minus 1 times d square times 2n square minus 6n plus 3n becomes minus 3n plus 4 minus 3 becomes plus 1. And this means that this is n by 2 times 6a square plus 6ad times n minus 1 plus Now you can see that 2n square minus 3n plus 1 is can also be factorized, right? This can be factorized as 2n minus 1 times n minus 1, and this is what we will get as the expression for 3s. Okay, remember that this is still equal to 3s from here, right? This is still equal to 3s. So what is s going to be? Finally our s is going to be n by 6 times 6a square plus 6ad n minus 1 plus d square times 2n minus 1 times n minus 1, and finally we are done. Now imagine what happens if our AP is just integers, positive integers. Suppose our AP is, so what happens if our AP is, let us use a different color. If our AP is natural numbers, so in that case our first term is 1, so a is equal to 1. Then second term is 2, so common difference is also 1. 3, 4, and the nth term would be n, right? Now suppose I want to find what is the sum of the squares of natural number. In that case all we have to do is, in this formula we put a as 1 and d as 1. So we get this is equal to n by 6 times 6a square will become 6 plus ad will be 1, so this will become 6n minus 6 plus d square is 1, so this will become 2n square minus 3n plus 1, so this will be plus 2n square minus 3n plus 1, and if you simplify this, this becomes n by 6 times 2n square minus 3n and plus 6n gives you plus 3n, and 6 minus 6 is 0 plus 1, and therefore the sum of the squares of n natural numbers is equal to n by 6 times, this can be factorized as, you can see that 2 times 1 is 2 and the sum should be 3n, so it is 2n plus 1 times n plus 1, and this is the formula for sum of n natural numbers, sorry, formula for sum of squares of n natural numbers. And we are going to use this in the further problems from the exercise of Hall and Knight. Okay, so this formula is useful. This is simply sigma n square.